So this video is the last one in the series showing you how to use the CrystalGrower visualizer, and it's going to focus on showing you the high throughput mechanisms built into the software. So I've got a folder where I've got several simulations of MFI, a zeolite structure, partitioned with natural tiles. And that's a key point about all the options I'm going to show in this video. They perform operations on directories populated with XYZ files. So here I've got 6 XYZ files. It doesn't matter what they're called, the visualizer will search for the XYZ extension and process each file sequentially. So each of the files that you've put in a directory have to be from the same structure, i.e. they have to have the same .viz file. So I mentioned previously that you could open different simulations on the same structure without loading the .viz file, and that's exactly what the high throughput procedure does. So let's open our .viz file and then open some coordinates to start with. So I'll open that .viz file I just showed, and then I'll open the first set of coordinates. So this here is a structure that hasn't been colored with layer coloring. So if we were to do some high throughput procedures, we wouldn't be able to do any layer coloring because it's all going to be defined by the simulation we have open currently. So if I say layers, it won't let me open it. If I swap over to the second simulation, this is actually a layers file, so we'll get access to all those layer options. And there is a reason I've shown that. It shows what happens if you mix simulations together. So it won't crash, but it won't be able to render the first file with layers because that option isn't available. It'll just give you an empty image, but it will process everything that has layer coloring as layer mode. So the main point is whatever you have displayed on your screen when you trigger the high throughput mode is what it's going to use to process all the files. So whatever viewpoint I set, it's going to retain that through the whole folder. So if I zoom far away, if I change some colors or resize anything, it's going to take that through all the simulations that it processes. So if I change this to green and I change the next layer to red, these colors are going to be retained throughout the folder. So now let's trigger one of these options. First of all, I'm going to show you the folder. It has no bitmap images stored in it yet. So if I go back to the visualizer, press File, Process a directory. This is the first high throughput option. The most simple one is single image. So that would just take a single image from each of the simulations that you have in the folder. Aside from movies, so for movies it'll capture all the frames, it'll take a single image of those. So you can high throughput process movies as well. So if I press single image, it'll warn you that it takes a long time because this does take a few minutes to go through all the simulations in a folder, especially if you've got lots of movies. And if I view these as details, you can see I've got 2 movies in here, some very large simulations. So it'll take about 2 or 3 minutes to process this folder. So I just have to select one of the files in the folder and press open, and it'll start to process everything. And if we go back to our folder, you can see it's processed the first file, it's processed the second one, and everything always has the name starting with the name of the simulation the file originated from. So it's processed the 3 non-movies very quickly, and now it's got to the 4th file here, which is a movie, so that's going to take a while to process. If I open this first simulation, which we showed was a tile-based simulation, you can see it's tried to capture an image there, but it hasn't processed it because layer coloring wasn't available. The second simulation was fine, and so was the third simulation. And the rest of the files in the folder will be processed as well, as they're all layer-based movies. Once the high throughput has finished, we can see in our folder that we've got loads of new files. So the simulations 4 and 5, there's 50 frames each because they were 50 frame movies. So if we view these as large icons, we'll be able to see a quick image of what they look like. So you can see the simulation of the crystal growing over time here. And also in number 4. And then you'll see number 6 hasn't rendered either. That's because that's also a tile-based simulation. That'll be important in the next thing we try. So if we go back to the visualizer, A dialog box has appeared to tell you that the simulations have been processed. If we press OK, it's loaded the last simulation that it processed, which was a tile-based structure, so it defaults back to tile colouring. So now let's try another high throughput mechanism built into the program. I'm going to reload a layers simulation. So I'll load number 2 again. You can see the viewpoint is still large enough to capture the big crystals in the frame. So this time we're actually going to process as tile colouring instead. So I'm going to switch to type tiles. I'm going to change some colouring to show that it's retained while processing the directory. I'll pick these purple tiles here. I'll change them to something quite obvious, something like red. And this time I'm going to process a directory, but I'm going to cycle species types. It's going to cycle through all the species in the system and show them one by one. So for tile structures, it's going to show each tile type at a time, just that one tile type. For molecular crystals, depending on what you've got selected, it'll either show spheres or atoms and cycle through the atom types. And for tile-based structures, if you're showing spheres instead, it will process the species one by one as spheres, rather than showing tiles. So I'll do this again. You have to specify it the same way. You choose a directory, and it will process all the files and give them an automatic name. So the naming convention is the name of the simulation. It'll have something like tile type 1 or species type 1 after the name. So this once again takes a while because it's got to do the same processing as it did the first time. So as soon as I press open, it's going to process all these files for about 2 or 3 minutes. And if we navigate back to our directory, we'll be able to see some new files that have been created. So the first simulation, which it previously couldn't process, it's now managed to process because it's a tile-based structure and we've given it tile-based colouring. So it can process that. And that's the images that you'd get. If we go to simulation number 2, the same things happened there. Tile type 1, 2, 3, 4, all the way up to 10. And it's going to do that for all of these simulations. Once it gets to the movies, instead of doing this per frame, because you'd end up with 500 pictures, it's going to only skip to the final frame of the movie and show each tile type for the final frame. Because the final frame is usually what you're interested in. And we've got a dialog box to show us the simulations have finished processing again. And if I press OK, it will load the final simulation in the directory. So if we go back to our high throughput folder, you can see that we've generated all these tile images for every single simulation. So we've got tiles 1 to 10 for simulation number 1, tiles 1 to 10 for simulation number 2, number 3, 4, which is a movie, and if we scroll down we've got 5, which is also a movie, and finally number 6. But so far we've only shown still images. There's one other high throughput mechanism that's built into the visualiser. If we go to File, we've got Process and Rotate Movie. These are designed to give you a quick overview of your simulated crystals in a directory. So it'll go through each file sequentially, like the rest of the options do, but it'll take 8 images of your crystal rotated around an axis. So you can choose X, Y, or Z. So this produces a lot more data, but it gives you a quick insight of how your crystal morphologies change over a set of simulations. So for example, if you changed one energy parameter and put all those simulations in a folder, you could process them quickly like this and get some idea about how the morphologies changed relative to the energy parameter. So in this example, I'm going to process about Y. And again, it says it'll take a long time, and it will retain whatever options you've got set on the screen currently, and it will start from the viewpoint that you're starting at. So first of all, I'm going to reset my simulation to a good viewpoint. I'm going to rotate my crystal slightly off axis, and then I'm going to process and rotate about the Y axis. It warns you again that it'll take a long time, and I'll just choose the directory that I was in before. And then we again have to wait for it to process all the files again. But we'll end up with a set of images for each simulation where the crystal's been rotated around the Y-axis in 45-degree increments. And for the movie simulations, the same thing that happened when cycling through the tile species will happen. So it'll skip to the final frame, then take the rotation image, because your final crystal is generally the one that you want to look at. And we can see our simulations have finished processing again due to the dialog box. And then we can go back to our folder and see all the new images that have been created. So we've got the series of images here per simulation. So it's captured 9 frames as it completes a full rotation around the crystal. So if we look at simulation 2, for example, and scroll through these, you can get a good idea of what the crystal looks like. If you imagine a folder full of simulations with this set of images for each of your crystals, you could just hold down one of the arrow keys and scroll through each of your simulations and get a good idea of the crystal morphology really quickly. And while they're processing, you can get on with other work. The other 2 options work the same way, but they just rotate around the x-axis or the z-axis. So that's a quick overview of the high throughput methodologies built into the CrystalGrower visualizer. I hope this series of videos has shown you how to effectively use the CrystalGrower visualizer, and it's given you some ideas of how to use it in your own research.